Hey, welcome back. In previous video we have seen filter method, map method and limit method. Now we will see one another method which is sorted method. If you want to sort elements of the array or list, you can use the sorted method upstream. Now there are two types of sorted method in the streams. The first one is sorted and the second one is sorted, which accepts a parameter comparator object. Now sorted method can be used which do not accept any parameter in case of natural sorting order. If you want to sort your elements in natural sorting order, you can go with the first method, which is sorted. But if you want to sort your elements in customized sorted order, then you can use the comparator to create your customized sorting logic, and you can pass this comparator object as a parameter to the sorted method, and you can sort your elements in customized sorting order. So we will see both the methods. We will go one by one, and let's see the first method, sorted method, which do not accept any parameter. And in case of the first method, we will be sorting our elements in natural sorting order. The sorted method, which do not accept any parameter, it returns a string consisting of the element of this string sorted according to the natural order. Now this is the important part. It will always sort elements in natural sorting order. It may throw ClassCastException if the element of the string is not comparable. We will see this point in example. Do not worry about it. Just remember that your element of the string should be comparable. If it is not comparable, it will throw the ClassCastException. And this is an intermediate operation. It means the sorted method will always return a string, and that's why it is an intermediate operation. And this is a simple method signature. So let's see one simple example for the sorted method in Eclipse, and we will understand it better. Okay, so let's create one class test and add the main method. Okay, so here we will be creating one simple list of elements which will be integer, and we will add 1 to 10 numbers and we will sort it. So let me create one list of integer. Let's say list, and we will be adding arrays as list. So here I will add 1 to 10 numbers in not sorted order, that means in random order, so that we can prove that we will be sorting these numbers using sorted method of the string. So here I will add 1 to 10 numbers. Okay, so let's import the list. Click on the list and press Ctrl+1 to see all the suggestions, and you can see import list from java.util package. Just press enter, and okay, now error is resolved. So we have a list. Let's add a simple sysout statement so that we can simply print that list. Okay, and now I want to sort these numbers using the stream. So let's create a stream of the list. So list.stream. Now we have a stream and we can sort it. So using sorted method, you can see there are two options here. The first one is which do not accept any parameter, and we will select this one so that we can sort using natural sorting order. And this is an intermediate operation, so it will return a string, and to collect it in a list or array we will be using a collect method, which is a terminal operation. So let's collect it in list. So collectors to list. Okay, yeah, add the semicolon, and we will be collecting it in a list. So let's create one list here, list of integer, and let's say it is a list 2. Okay, add this is out statement so that we can see the sorted list. Add a new line here, and it will be list 2. Okay, save it. And now I will run the program. So run as Java application. Okay, you can see the list 1, which is in random order, as we have added in the list. It is list 1, and you can see the output here. It is in sorted order, and which is list 2. Let's add a 2 here, save it. Okay, so this is a list 1 and it is a list 2. So it is in a random order as we have added in the list, and it is in sorted order. So we have used the sorted method to sort the elements of the stream in natural sorting order. We have seen a simple example for sorted method, but the second point we have discussed earlier is if the elements of the streams are not comparable, it will throw the ClassCastException. We need to check this point. So we will see one more example where we will get the ClassCastException where our elements are not comparable, and we will see how can we resolve it. So let's move to the Eclipse again. Okay, here I will create one more class and I will give it a name test2 and add the main method. Okay, so here I will be creating a list of custom class. The custom class is employee class, which we have created earlier in our previous videos. So to be precise, it is present in lambda expressions in collections. So this is an employee class. So do not worry about this class. It is a simple class with two variables, integer ID and string name. We have added a simple constructor, which is a constructor with parameters and setters and getters methods for all the variables, which is ID and then name. And at last we have added a toString method so that we can print the employee class. This is the class which is used in the previous examples, and if you want to just see it, you can simply refer to the GitHub repository link that I have given in the description. So do not worry about this class. This is a simple custom class named employee, which has two variables and its respective constructor, getters and setter, and toString method. That's it. Okay, so we will come to our test2 class. So here I will create a list of employee. Okay, I will give it a name list, and first we will import it. The list Ctrl+1 to see the suggestions, and import list from java.util. Okay, now we need to import the employee class because it is present in some other package, and Ctrl+1 import employee from other package, which is our previous example package. Okay, now here arrays dot as list, and here we will be creating employees. So let's say new employee, and since we have added the constructor, it is giving us an option integer id and string name. So id will be 101 and name will be Shubham. Okay, let's create another one. I will simply copy it. Okay, and give it a name. Okay, and id should be 3. We are giving it in a random order so that we can prove that we will be able to sort it. Okay, now we have a list of employees ready with us, and we will be sorting it so that I want to print my list according to the ID. So the Shubham will be printed first because it has 101, and then John will be printed because it has ID 102. So this is the simple list, and now we will be applying the sorted method so that we want to print all the elements in natural sorting order of their ID. So let's get a stream. So list dot stream. So we have a stream now, and apply the sorted method. Sorted method, we will be using the first one because we want to print all the elements in natural sorting order of their ID. And here we will be applying the terminal operation collect so that we can collect all the elements in another list. So collectors dot to list. Okay, and create one list here, list of employees, give it a name list 2. Let's add some simple sysout statement so that we can print both the outputs. So sysout. Okay, this is a list 2 sysout, and add a simple one for list 1 also. It is a simple list. Okay, so our example is ready, and we will simply run it. So save the example and run it. Run as a Java application. Okay, so let's see what happened. And here we can see we are getting a class cast exception. We can see the list 1 is printed, but at the test2.java line number 24 we are getting an exception where we are trying to apply the sorted method, and the exception says, let's read the message here. It says employee cannot be cast to java.lang.comparable. That means our employee object is not comparable, and that's why we cannot use it as element in sorted method. So how can we resolve it? It has a simple solution that we have to make our employee object comparable. And how can we make it? By just implementing a comparable interface to it and overriding a compare to method. So let's make it compatible. So we are at our employee object, and here I will add the comparable interface. So public class employee implements comparable, and what we are trying to compare? Employee. Okay, so we have added a comparable interface here, but as soon as you add a comparable interface, it says there is some compile time error, and once you hover on the employee, you will say add the unimplemented methods. That means the interface comparable has some method which need to be implemented. Here you can see that we are overriding the compare to method, and as we have discussed earlier in the example that we will be comparing employees on the basis of their IDs. So I will say this dot get ID compare to O dot get ID. Now O is the object that we are passing, and this is the object that we are referring to. This is the current object represented by this, and the O is the one we will be passing. Okay, so we have overridden the compare to method. Save this employee object and we will come to test 2. Let's clear the console and I will run it again. Okay, now you can see the list 1 and list 2 is printed. The list 1 is the one we have created. It has 101 Shubham and then 103 Gaurav and like 104 Radha and 102 John. But the list 2 is the sorted one. It has 101 Shubham and then 102 John. In case of the list 1, it is 103 Gaurav, but since the list 2 is sorted according to the IDs of the employees, it is 101 first, 102 second, and so on. You can see the output here. So that's it for the sorted method without parameter. We have seen 2 examples. The first one is with simple list of integers, and second one is with the custom object which is employees, and we have checked the condition for ClassCastException and we have seen how can we resolve it. Okay, so we have seen sorted method which do not accept any parameter, but now we will see the sorted method which accepts a comparator object. We know that comparator object is used to provide custom sorting logic. So sorted method will return a stream consisting of the elements of this stream sorted according to the provided comparator. This is an intermediate operation. That means it will always return a stream. And this is the method signature. So let's see examples related to the sorted method which accepts a parameter. Okay, so this is the first example test, and here we have taken a list of integers and added numbers in a random order, and this is a list 2 for which we are just sorting using the simple sorted method which do not accept any parameter. And in case of this method, the elements will be always sorted in a natural sorting order, and we know that for integers the natural sorting order is ascending order. So let's simply run it and we will see if it is printing. Okay, we can see it is printing in natural sorting order. We have seen this example for sorted method, right? So we will improve it so that we can pass some customized sorting order. So we have printed it in ascending order. Now how can we print it in descending order? So for that we have a sorted method with comparator object, and we can pass the logic for our descending order sorting. So let's create one comparator from java.util, and we will be sorting integer. Let's say C. We know that comparator is a functional interface because it has only one abstract method. So let's see, it is compare. It has only one abstract method, compare, which accepts two parameters of any type. So here we will be writing a lambda expression for our logic. So if you are not sure how can we write lambda expression, I will recommend you to check my first video where I have explained very well how can we write lambda expressions for various cases. I have given the link in description. So here we will be taking two parameters as an input. Let's say I1 and I2. These are our two integers which gives, and here we will be expecting it to print in a descending order, and that's why I will take I2 compare to I1. Okay, now it is a logic for descending order, and here we will take a stream on our list. So list dot stream, and here we will be using the sorted method with comparator object. So select the second one and press enter, and here our C is comparator object here. Okay, and this is an intermediate operation, so it will be always returning a string. To get our result, we have to use the terminal operation, which is collect, and here we will be collecting it to the list. So collectors dot to list. Okay, add the semicolon and let's collect it in a list. So list of integer, and I will give it a name list 3. Okay, save it, and we have a list 3. Simply add the print statement for list 3. Okay, save it. Now I will clear the console and let this program run again. Okay, so you can see this is the list 1, which is the simple random elements that we have added in the list. List 2 is the one where we have used the sorted method without any parameter. That means it will sort the elements in natural sorting order, and for integer the natural sorting order is in ascending. You can see 1, 2, 3, 4, 5 and so on. Now here we want to print the elements in descending order, and how can we pass the customized sorting logic to the sorted method? Using comparator. You can pass the comparator object as a parameter to the sorted method, and it will sort our elements based on the comparator. And at the comparator we have written a lambda expression which says print our element in descending order, and we have printed the list 3, and you can see the list 3 is printed in descending order, 10, 9, 8, 7 and so on. So this is the simple example for sorted method with comparator. We have seen it for numbers, integers from 1 to 10. But we have seen a second example for our employees class, where we will be printing our employees in ascending order of their IDs. So let's improve this example so that we can pass some customized sorting logic using comparator. So clear the console. Okay, and this is stage 2 where we have added some employees to the list, and in list 2 we are simply sorting it in its natural sorting order, and the employee class implements the comparable where we are overriding the comparator method. So here it will print all the elements according to their IDs in ascending order. So let's simply run this program. Okay, you can see 101 Shubham, 103 Gaurav, because it is in random order. Since we have added it in random order, at least one, at least two, we are sorting it in natural sorting order of their IDs, and you can see 101 Shubham and then 102 John, and so on till 3, 4 and 5. Okay, so here we want employees to print in descending order of their IDs. How can we do it? We can use the sorted method with comparator. So let's create one comparator for it. Comparator of employees, because we will be comparing employee object here. See, and here we will be again writing a lambda expression. You can check the video and description how can we write lambda expression for various cases. So here I will be getting two parameters, let's say obj1 and obj2. Okay, it gives. Now here I will be writing a logic for compare method of comparator interface, and I want to print all the employees object in descending order of their IDs. So I will be checking object 2 first, dot get ID dot compare to, and here we will be taking object 1. Okay, so this is the logic to print employees in descending order of their IDs. Okay, and here we will be taking a stream on list. So list dot trim, and the sorted method we will be choosing the second one with comparator presenter, and our comparator object goes here. Since this is a intermediate operation, it will always return a string. To get our result, we need to add a terminal operation, and it is collectors dot to list, because we want to collect it in a list. Okay, so let's create one list here, list of employee, list 3 and list 3. Okay, save it. Add the simple sysout statement below list 3, so that we will be checking list 3. Okay, I will clear the console and run this program again. Okay, see, now we will be seeing list 1, where we are printing the employees in random order as we have added in the list 1. Okay, at list 2 we have used the sorted method without any parameter. In that case, our employee class need to be implementing the comparable interface so that we can sort it. Otherwise we will get an exception, class cast exception. We have seen this case in the previous example. Our employee object is implementing the comparable, and we have overridden the compare to method, so that our sorted method is working fine, and we are printing the employees object in ascending order of their IDs, because sorted method will use natural sorting order. And sort with parameter as a comparator, we can pass some customized sorting logic. In case of this example, we want to print employees in descending order of their IDs, and we have written a logic for it. You can see this is the comparator that we have written, and we want to print it in descending order of their IDs. And you can see the output list 3. It is printing 105 Mike first, and then 104 Radha, and then 103 Gaurav, 102 John, and 101 Shubham. So it is printing in the descending order. So I have shown you how can we pass the customized sorting logic using comparator, and we have printed the employees in descending order. So this is a simple example for sorted method with comparator object. Now that's it for this video, and we will see the next method in upcoming video. Thank you.